Okay, so it's like I said, rational functions number 2. And we are graphing rational functions. The first thing that I'm going to show you is what the graph of 1 over x looks like. I'm not going to go into making a table of values and doing all of the things. I'm just going to show it to you. This is what we're working with. This is what we're going to scoot all around the page using our transformations. So we're just going to plug in some x values and figure out what the y value would need to be if our equation is 1 over x. So let's just start with 1. What is 1 over 1? Y'all can show me with your finger. 1 over 1 is 1. So when x is 1, y is 1. Cool. What's 1 over 2? A half. So when x is 2, y is a half. So we're going to be a half. What's 1 over 3? You can mouth it. It's a third. So when x is 3, y is a third. Same thing, x is 4, y is a fourth. It's going to get closer and closer to the x-axis, but we're not actually going to cross it on the positive side, because if you have 1 over a number and that number is positive, isn't 1 over a positive number still going to be a positive number? Yes. So we're not going to get into the negatives. We're going to get really, really close, but we're not going to touch the x-axis. We'll have an asymptote on that line. It's going to go in both directions, so we can go ahead and draw it. This is on the x-axis. We're going to have an asymptote. Let's do our negatives and see what happens there. What's 1 over negative 1? Negative 1. Okay. 1 over negative 2 is negative a half. Then we have negative a third, negative a fourth. We're getting really, really close to that asymptote in this direction. So we have a little space in between negative 1 and 1 where we're not really sure what's going on right now. Can you divide by 0? What's 1 over 0? Can you divide by that? No, it's undefined. So at the y-axis, where we've got 0 here, we actually have another asymptote. We've got a vertical and a horizontal asymptote. And what happens, it's kind of neat. If you're thinking about between 0 and 1, if I was going to plug in 1/2, 1 divided by a half is 2. 1 divided by a third is 3. 1 divided by a fourth is 4. Same thing on the negative side. 1 divided by negative 1/2 is 2. Then we got 3. Then we got 4. And we're getting closer and closer to our asymptotes, but we're not actually touching those. So our graph, they've got 2 parts. And they look like that, the 2 parts. So with our rational functions, where we have an x in the denominator and it doesn't end up canceling out overall, our graphs will look in a similar fashion to this, where we have asymptotes. We've got them defined in certain sections of the graph. So we're going to talk about transforming this and shifting it and where the numbers go, if you're shifting it left or right or up or down for this. So here's our transformations. So you can have a plus or a minus in the front. Normally it's on the top of the problem, but it could be at the very beginning. So we're going to write down what all these different things do for our graph. So our basic graph is sitting right here, a 1 over x, but we have all of these little transformations that can happen. It could be a plus or minus in the front. We could have a number multiplied on top. We can have a number with the x on the bottom. We can have a number added at the end. All right, so a number added at the end of a function, what does that do to our graph if you've got something added at the end? How does that shift it? It shifts it up or down, right? So if we have a number at the end like this is going to move our graphs up or down. And these transformations just work if they're sitting in this form. If we're going to have another form in a little bit that we have to do some other stuff to figure out all the transformations. If you have a number with the x, which way are we going if we have a plus or minus with the x? Left or right? Remember, a left is going to be what kind of sign? Plus sign. A right is a minus sign. A number multiplied is going to be a vertical stretch or vertical compression. We don't do a whole lot with that with these, but vertical stretch or vertical compression. And if it's in transformation form and it is positive, a positive graph looks like the graph that we just drew, where it's going to be, these are the asymptotes and our graph is right here. So what do you think a negative is going to do if you have a negative in front of the graph? How does that affect it? It flips it upside down. So what was in this first section is going to be underneath that line. It's going to be here, and the other one is going to be there. Okay. So we're going to do one transformation one. We'll write out what the horizontal, vertical asymptotes are, also the domain and the range for extra practice. For these graphs, they don't have to be super precise, but I do need you to have them, the asymptotes in the right spot and also be drawn in the right section. So based on if it's positive or negative. All right, so let's write down what all of these things do. We only have two transformations in this case. The x minus 2 is telling us our graph is shifting how much? 2 to the right. So this is going right 2. And the plus 4 tells me that I'm going which way? Up 4. Okay. So my asymptotes, my new asymptotes, instead of being on the x and the y axis, I'm going to shift over 2. So there's one that's going to go this way. That's just a stray dot right there, so ignore it. And the other one's going to go up 4. So 1, 2, 3, 4, make my asymptote. So I went to 2 and did an asymptote, and then I went up to 4, made an asymptote. And this is a positive graph. We don't have a negative in the front or a negative with the 1 on the top. So positive means we are in the first and third kind of quadrants for our asymptotes. So we're going to sketch our graph here. And we're going to sketch our graph here. All right. So there and there, let's go ahead and write down what our horizontal asymptotes are and our domain and our range. Horizontal and vertical. Horizontal, vertical, we'll do domain and also range. Is horizontal across or up and down? It is across, right? Where is the asymptote that goes across? What number is that? It's at 4. So our horizontal asymptote is the line y equals 4. Y equals lines go straight across. Our vertical asymptote, what is its number? 2, and it's an x value, so x equals 2. It goes through the x value of 2, up and down of 2. Now, our domain are the things that x is not going to equal. So that's where our asymptotes are. If I'm going across the x-axis, where is my asymptote that's going to tell me that I can't have an x value? It's going to be at 2. So my domain is x cannot be 2. And our range, what is the y value that we can't have? Our y cannot be 4. Your horizontal and vertical asymptotes will correspond with your domain and range on this type of graph, if you don't have any holes in it, which we'll get to in a minute. Okay. What I want you to do right now, I want you to take a pause on the notes. We've got another rest of a type of graph to do. I want you to get onto CUDA, onto the rational functions number 2. I'm going to give you 5 minutes. I want to see how many of these transformation graphs that look like this that you can get done in these 5 minutes. Okay, once you get to some weird ones with x squareds and stuff, stop. I'm going to see what problem number that is. I'm going to stop actually, I'll just edit the recording in a minute. So go ahead, get on the CUDA. 5 minutes. We'll come back at 9:20 to finish the rest of our notes. Okay, so the next kind, these are other rational functions graphs that aren't just written in transformation form. So when you have something that is not just that set up in that format, you'll have stuff on x's on top, x's on the bottom. We have got 5 things that we have to find before we can graph our rational functions. Then we do them in a specific order because it makes it easier for us to remember. Okay, so I'm going to write down the order that we're going to use. I use some little symbols or abbreviations at the side when I'm working these problems out, just so I remember to do all of those. Okay, so the first thing that we're going to find, and we're going to go through in a minute and I'll tell you how to find all of these things, but I just want you to have the list at the beginning. So the first thing that we want to find are our horizontal asymptotes. We do that at the very first. That's number 1. After we found our horizontal asymptotes, then we want to factor. That's our next step. We don't get any number out of that, but that's the next thing that we do. So we factor after we found our horizontal asymptotes. The next thing that we're going to find are our holes. Then we'll find our zeros or x-intercepts, whichever one you want to call it. Then we'll find our vertical asymptotes. Then we can do our y-intercepts. We can do our y-intercepts kind of anytime we want to. I just normally do it at the very end. Okay, and this is my little abbreviations and things to help me remember it. I mean, I just abbreviate them. So I say ha, and then I'll go this, and with a line through it. z over va, and then yint. So I just write it in this order, ha, ho, z, va, yint. I cross through for the holes. I separate the zeros and the vertical asymptote with a line, and you'll see when we're working the problems why that's the case. That is my little way to remember it and remember what goes where and where I can figure out where all these things are. Okay. All right, so we're going to start out with horizontal asymptotes and how we find those. So for our horizontal asymptotes, we are going to find the terms in our function, on our fraction, that have the highest power overall for the whole fraction. So you want to find the highest power overall in your whole entire fraction. Once we've identified what that power is, you're going to look at the coefficients that are in front of the terms that have that highest power. So once we do that, we are going to write the ratio of the coefficients of that power. So you look at the top, you find that power, you write the number that's in the front. You look at the bottom, you find that power, you write the number that's in the front. So we're going to look at 3 examples and find the horizontal asymptote because there's 3 different cases that could happen with these. So we'll write them all down first and then y'all can help me figure them out. We have 5x squared plus 1 over 2x squared minus 2. 3x to the 4th plus 2x over 4x to the 5th plus 1. Then 6x squared plus 1 over x plus 5. I'll give y'all a second to write that down. All right, let's take a look at our first one. We want to find the highest power overall. So look at all of these terms. What is the highest power that you see? 2, the second power. Okay, so I'm going to circle it. Those are my second powers. Cool. I want to write the ratio of the coefficients of that power. So the number in front of the x squared term on the top is a 5, and the number on the bottom is a 2. So my horizontal asymptote is 5 over 2. So that would be 2.5, and you would go at 2.5, and that's where you're going to draw your horizontal asymptote. Okay, you okay with that? All right, in our second one, what's our highest power that we see? The 5. Okay. Is there a 5 on the top? No, so I'm going to write in the front that I've got 0x to the 5th on the top because I'm looking for my highest power. I need to have one from the top and one from the bottom. So I've got 0x to the 5th. So if I write this down, I have 0 on top and 4 on bottom. And what is 0 divided by 4? 0. So my horizontal asymptote is at 0, which just goes along the x-axis. Thumbs up if that's okay. Okay. All right. Our last one. What's the highest power that you see? A 2. Okay. I've got a 2 on the top. That's cool. I don't have one on the bottom, so I'm going to put 0x squared on the bottom. So my horizontal asymptote is 6 over 0. Can you divide by 0? No. So we're going to write there is no horizontal asymptote. Okay.
Miss Roselle, for the first example that you did, we will go with 5 divided by 2 on the white axis.
You do 5 divided by 2 on the, it just goes across at 2.5. You'll drive a horizontal line at 2.5.
Okay, thank you.
Uh-huh. We'll do one all together once we know all the steps and put it on a graph. I just wanted you to see the different cases for horizontal asymptotes. Okay, so horizontal, you do that before you factor. So once you've found your horizontal asymptote, then you're going to factor your problems just like we did with rational functions. Okay, so if you want to put that there, if you're going through your steps when you're working your problems, the next thing that you're going to do is factor. That comes next. After we factor, what's next on our list to find? What did we write down for number 2? What was next to find? The holes. We're going to find the holes. So what holes are places where the graph doesn't exist, but it's not an asymptote. Okay, so our holes come from the factors that we can cancel out. You know, we were doing our problems and we were like, I got x minus 2 on top and bottom, and that can go away. That's going to result in a hole in our graph. So when we're actually figuring it out, a way to say this is what makes our canceled factors equal to 0. So holes come from what you cancel out. That's why when I wrote my abbreviated thing on the side, did you see how I wrote a slash through holes? Because holes are what gets canceled out. Okay, so we'll look at one real quick that we'll factor and then see what our holes would be. So if I had x squared minus 4 over x squared plus 5x plus 6, and I want to see what my holes are going to be, I need to factor first, and then I'll see what gets canceled. Okay. What would our horizontal asymptote be on this one before we do our factoring? It's going to be 1, right? 1 over 1, which makes 1. And so now we'll factor x plus 2, x minus 2. That's a difference of squares. And what are our two things that multiply to 6 and add to 5? 2 and 3. So x plus 2, x plus 3. So what is going to get canceled out in this problem? The x plus 2. So x plus 2 gets canceled out. That's gone. So what would be our 0, or what would make this equal to 0, the x plus 2? Negative 2. So we have a hole at x equals negative 2. So you'd go to negative 2 when you drew your graph, go to where your graph is, and we're going to put a little hole there. So we'll graph this whole thing together in a minute. All right, so holes, you cancel your stuff, and it's whatever makes that canceled factor equal to 0. All right, once you've canceled something for your holes, we don't use it again. So once it's canceled out, it doesn't show up for zeros. It doesn't show up for vertical asymptotes. So our next thing that we're going to find are our zeros, which graphically are our x-intercepts. And our zeros are what makes the top equal to 0 from our fraction. So if we can continue with this problem, I don't use the canceled factors anymore. X plus 2 over, or x minus 2 over x plus 3. What is going to make my, the top of my fraction equal 0? What number? That's going to be 2, right? So my x-intercept, or my 0, is 2. Comes from the top. Number 4 is our vertical asymptote. That is what makes the bottom equal to 0. So we'll use the same problem. X minus 2 over x plus 3. What would our vertical asymptote be? Negative 3, right? So our vertical asymptote is negative 3. And our one thing I want to show you real quick, I know you're still writing this down. If you look back up at what I wrote on the side with my initials over here, I'll scroll back down a second. I crossed out the holes. I put zeros on top and vertical asymptotes on bottom because zeros come from the top. I always separate those with a line. Vertical asymptotes are on the bottom. So that helps me remember when I write this in this order. I do that first with my powers. That's what gets canceled. This is from the top. This is from the bottom. And then y-intercepts will do right now. So hopefully that little picture helps y'all out. And then y-intercepts, we do y-intercepts just like always. You plug in a 0 for your x's. This is just like we've done before. So our x's are going to go away. So what would our y-intercept be for this problem? It'd be negative 2 over 3. Okay. So 0 minus 2 over 0 plus 3, which is negative 2/3. So we're going to put everything together, and I'm going to show you how, using all of these 5 things, we can figure out where the graph needs to go, where the asymptotes are, if it's in first and third quadrant versus second and fourth, because you can't tell that just by it being negative or positive, because these are all just a little bit weird. So now we're going to graph it, do all those things together for this problem. So we had our ha, then our ho, then our z. I'm just going to write it all together down here so we can see it. So this is the same one that we just did, but we did all of these steps. So we set our horizontal asymptote. I'll let y'all write that down 1 second. Our horizontal asymptote, we said that was 1, right? Because 1 over 1 for the highest power stuff. Our holes, what were our holes? Hole was at -2. Our 0 or x-intercept was at 2. Vertical asymptote -3. And y-intercept -2/3. So let's put all that together on a graph. When you're doing this, you always want to draw your asymptotes first, then plot your x and y intercepts. Then we'll do the holes after we've sketched our graph. So our horizontal asymptote is at 1. Vertical asymptote is at -3. We want to go ahead and put our 0 and y-intercept, so that's x and y-intercept. X-intercept is at this point, we don't know if our graph is here and here, or if it's here and here. We can't tell. It looks like it might be something that's positive, but we're not sure. It's really strange with these because the squares modify what we think might happen. So we're going to put our x and y intercepts, and that's going to let us know what's going to happen with these graphs. Because they're always in diagonal sections, so it's going to give us a clue. So our x-intercept is at 2, and our y-intercept is at -2/3. Okay, so we could either be in first and third quadrant, or we could be in second and fourth. But we have that our x and y-intercepts are in this fourth quadrant section, so we have to have in the second quadrant for the other part. They've got to be diagonal from each other. So once we know, okay, our graph is going to be down here, the other part has to be up here. So we use our x and y intercepts as clues. Let's go ahead and draw this. It's going to look like here. This one here. And we have graphed everything on here except for what? We've done the horizontal asymptote. We've done the vertical asymptote. We did the x and y intercepts. We need to put the hole on there. So our hole's at -2. So you go to -2 on your x-axis, go to where your graph is, and you make a hole. So that is at x equals -2. Go to where your graph is and make a hole. You can do a little erasing if you need to, right there. So you see how we used all 5 of these things to put the stuff on the graph together? When you do the, yes, Alan?
You said the hole was at -3, right?
-2.
Oh, no. Okay.
Yeah. Our vertical asymptote was at -3. And what you'll notice, you remember when we found excluded values last time, we would have found the excluded values on here were -2 and -3 from the bottom being factored. The excluded values show up either as an asymptote or a hole. So our vertical asymptote is -3, our hole is at -2. So excluded values will be your holes and vertical asymptotes. It's going to have to be one or the other for those. Okay. All right. So 5 things to do. I gave you some problems in the homework that are just like find just the horizontal asymptote or find just the holes. And then there are some where you have to find all of the things. So go ahead and get started. If you've got questions, make sure that you ask me. I didn't give you too many though on this one. Show your work where you're factoring when you need to factor. And this is due before next class period.